In this presentation, we will be discussing a second problem which is related to the electrical power in a series combination of resistors, in which a DC voltage source is connected in series with three resistors, let's say R1, R2 and R3. And the resistance value of the first resistance is 2 ohm and that of a second resistance is 4 ohms. And we are asked to find out the resistance value of the third resistor, and the potential difference across the terminals of this DC voltage source is 24 volts. So first of all, we need to find out the current in the circuit. So for that, as we know that the power delivered by this DC voltage source is equals to the sum of all the power absorbed by these components. So the power delivered by this DC voltage source is, let's say, PE, which is equals to the sum of all the power absorbed by these three components. So let's say the power absorbed by this first component is P1, plus the power absorbed by the second component is P2, plus the power absorbed by the third component is P3. So as we know that the power of this DC voltage source is I into E. I is the current in this circuit and E is the potential difference across the terminals of this DC voltage source. And the power absorbed by the first component is I squared into R1, plus the power absorbed by the second component is I squared into R2, plus P3 is given to us, which is 24 watt. Now E is given to us, which is 24 volt, is equals to I squared into R1 is 2 ohms plus I squared R2 is 4 ohms plus 24. So 24I is equals to, this will become 6I squared plus 24. Now by rearranging this equation, we get 6I squared minus 24I plus 24 is equals to 0. So in this equation, 6 is common in the left hand side of this equation. So by taking 6 common from the left hand side of this equation, so we get I squared minus 4I plus 4 is equals to 0. Now dividing 6 on both the sides, so we get I squared minus 4I plus 4 is equals to 0. So this equation is a quadratic equation. So by applying a quadratic formula, so we can find out the current from this equation. So the quadratic formula states that for any unknown x is equals to minus b plus minus under root b square minus 4ac divided by 2a, while minus b is the coefficient of this second component and a is the coefficient of the first component, while c is a constant which represents the constant term of this quadratic equation. Now x in this case is I, which is equals to minus b. So b in this case is minus 4. So minus into minus 4 plus minus under root b square. So 4 square minus 4 into 1, while c in this case is 4, whole divided by 2 into a, where a is 1 in this equation. The resulting current from this equation is 2 ampere. So 2 ampere of current exists through each point in this circuit. Now to find out the resistance R3 in this circuit, so as we know that the power equation for the third component is equals to I squared into R3. So I squared and P3 is given to us. So R3 in this case is equals to P3 divided by I squared. So P3 is 24 watt. I in this case is 2 ampere. So 2 whole square. So we get 24 divided by 4, which is equals to 6 ohms. So the resistance value of the third component is 6 ohms. Now it's all for today's presentation. If you have any doubt, ask in the comment section. See you in the next one.